Whoop. 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 Okay, sorry. All right, try it again. So fancy name, inorganic nomenclature. Okay, we're going to name inorganic compounds. Okay. Now, what I did was, you can read the book. There's nothing wrong reading the book for this chapter. If some of you just like reading, and when you read and by yourself and it's quiet, you might absorb more than listening to me. I don't know. It's possible. But what I've done is taken everything in that chapter and I put it into 5 categories. There are 5 ways to name compounds. And if you'll learn these, then you could look at a compound and say, oh, you're a type 1. I know how to name you. And I'm trying to make it easier for you. I'll never ask you what type it is. I'm just going to teach it that way so your brain has type 1, type 2. You guys in foreign languages, right? Didn't your teacher do something like regular verbs versus irregular? Did you guys something like that? Or anybody in Spanish? French? No? Latin? You guys take foreign language?
Yeah.
Okay. Don't you have some verbs that kind of follow one pattern and other verbs that follow another pattern? Do they call them regular and irregular? Okay, that's all they're doing. You know, if I was learning football teams, wouldn't there be some that, what are the divisions in football, NFL? What are they? Okay, and what else? Okay. All right, anyways, same thing. We just put them into categories to make them easy to learn. All right, are you ready? Is everybody ready? Here we go. Well, first of all, the easiest kind of compounds to name are type 1. Now, here is a word. What do you think binary means? What does binary mean? And if you're not one of guessing, you can read it. What does binary mean? Made of only 2 elements. Look at this right here. How many elements are in this? There's 2 right there. That must be him. Now, what else? What does ionic mean? A metal and a non-metal. The metal likes to lose and become an ion, a positive ion. The non-metal likes to gain electrons and become a negative ion. These are ionic. And one more thing. So if you're binary and you're ionic and you're one of these things called the always metals. Okay. Now, because I'm going to say the word always metals about 20 times in the next 2 days, you won't have any trouble knowing them, okay? So let me tell you which ones they are. All right, here we go. Not counting hydrogen. See this guy here? The alkali metals are group 1A. In a compound, they will always form an ion with a +1 charge. So 1A will always be +1. Look at group 2A. 2A will always be a charge of, I'm running out of batteries, +2. And then there are 3 more. Ready? It's a little mini stair step. Silver, come on. Oh. Darn it. Silver, zinc, and aluminum. Everybody see silver? Ag, Zn, Al. Everybody see that? Come on. Okay, silver +1, zinc +2, aluminum +3. So let's try it again. What are the always metals? Group 1A, look over the periodic table. 1A, in a compound, they will always have what charge? +1. Group 2A will always have what charge? +2. And then we have silver. What's the charge on silver? +1. Zinc +2, and aluminum. Everybody got that? Okay, now, does this fit the criteria? Is this saying a binary compound? And you can't even do this chapter if you can't tell me where the metals are. If you look up here, see a stair step? Darn it. All right, see this little stair step here? All right, not counting hydrogen. Anything below that stair step is a what? What are all these elements? They're metals. And what about here? Not including hydrogen, right? Everybody got that? Now, is this saying a binary compound? Yes, only 2 elements. Is it ionic? Is it a metal and a non-metal? Yes. Is it one of the always metals? Is that an always metal? Yes, it's in group 2A, isn't it? Then we're ready to name it. Let me show you how to name it. What you do is you write the name of the metal, just write it all out, say calcium, And then, see this here? See the metal? The nonmetal is called chlorine. But in a compound, the nonmetals, you drop the end of the element's name and add IDE, because all binary compounds end in IDE. All right, everybody look up here, okay? So I'm going to call this calcium, not chlorine, but what? Chloride. All right, now just to make sure you understand how this works, this is called fluorine, the element, but in a compound, what ion would it be? What's it called? Fluoride ion. How about this one? Chlorine, chloride. Bromine, the bromide ion. Iodine, iodide ion. Oxygen, oxide. Sulfur, sulfide. Selenium, selenide. Nitrogen, nitride. Phosphorus, phosphide. Arsenide, and hydride. Get that? So in a compound, the ion, the negative ion for a nonmetal is called IDE. Now, I need your attention, okay? Now, I don't know, I really need you. When we get off to a start, type 1's the easiest. If you get off to a bad start on type 1, you're really in trouble. All right, you okay on this? Okay, now let's try another one. What would you call this one? NaCl. You say, is that type 1? Is it binary? Yes. Is it ionic? Is that a metal and a nonmetal? Yes. Is sodium one of the always metals? Yes. Then what I'm going to do is say sodium what? What is table salt known as? Sodium chloride. Look at the next one. How would you name this one? BaCl2. Help me out, Aiden. How would you name it?
Barium chloride.
Yes. Next one. All right, Luke. How about this guy? Aluminum. Say it real loud.
Aluminum
Oxide. Oxide. Okay. Now, notice that for type 1, did it matter that this had a 2 and a 3 and a 2 and it didn't matter, didn't it? You don't look at the subscripts to name it. Is everybody with me? Are you sure? Okay, now, I need your brain to do two things. One of them is, if I give you the formula, can you tell me the name? That's pretty easy. The other one is, what if I give you the name, can you come up with a formula? So we're going to make our brain work in reverse. So let's try one. What is the most likely compound that will form between sodium and fluorine? Okay, so let's take a look. Come on, Laser. Come on, baby. I have some new batteries, but okay, ready? Okay. All right, ready? Now, so what we do here is, what charge does sodium have in a compound? What charge does sodium have in a compound? Okay, so let's put a little plus one right here. Now, what I didn't talk about is, what charge do the nonmetals take on in a compound? All right, ready? These don't like to form compounds, so we're not going to talk about them at all. These are noble gases. They don't like to form compounds. But these like to be -1, -2, and -3. Everybody got that? So let's take a look. Fluorine would tend to be what kind of ion? Okay, so let's do that. Now, all compounds have a net charge of what? If you add up pluses and minuses, if it's a real compound, what are they going to add up to? 0. Does this add up to 0? Then my final answer is, I don't need to write those pluses and minuses there now. I need one Na and one F. Let's try another one. What's the most likely compound to form between magnesium and nitrogen? This is a hard one. Some of you who think this is getting boring, this is a hard one. What is the charge on magnesium in a compound? Okay, +2. And what is the nitrogen in a compound? Not minus 1, not minus 2, but what? Minus 3. Now, this is a tough one. How are you going to make this add up to 0? And I'll show you a little trick. Whenever you have an odd and even like this, what's the smallest number that both of these go into evenly? 6. What times 2 is 6? And what times 3 is 6? Now what they're saying is, see that little 3 there? They're saying you have not one of those, not 2 of those, but you have how many? You have 3 of those. You have 3 of the magnesium ions. And how many of the nitride ions do you have? 1, 2. Now, add them up. What do you get? You got minus 6 and plus 6. Another way to do it. What's 3 times positive 2? That's plus 6. And what's 2 times minus 3? Minus 6. What's minus 6 and plus 6? Is that 0? Now we know how to write the formula for that compound. All right, you want to try another hard one? What's the most likely compound to form between zinc and phosphorus? What's the most likely compound to form between zinc and phosphorus? Everybody should be writing. Everybody should be writing. What is the charge? And I know I've only said it twice so far. I'm going to be saying it by 20 times by even tomorrow. In a compound, these are all plus. These are always 1A is always plus 1. These are plus 2, and then you have plus 1, plus 2, plus 3. Silver, zinc, aluminum. Those are the always metals, aren't they? Okay, so what charge, Hayden? What charge does zinc have in a compound? Say it again. Plus 2, isn't it? Okay, and what about phosphorus? That's a tricky one because it's not minus 1. It's not in a column minus 2, but what is it in? Minus 3. Okay, now this is almost identical to the one we just did, isn't it? So how are we going to make that add up to 0? What do you think, Hayden? What subscript do I put here? And these are superscripts. See them? They're superscripts. These are subscripts. Sub means below. What do you got, Hayden? And? What do you think? What do you think about type 1? I gotta look at your faces, okay? What do you think, type 1? We're gonna review type 1 tomorrow, aren't we? And then we're gonna do type 2. And you're gonna find out that type 2 is just like type 1, except one difference. There's gonna be one difference. And so if you know type 1 really well, I can teach you type 1, type 2 pretty easily.